Good afternoon. Again, I'm going to go about Distillery and how you guys might understand what it's doing in terms of the OTP releases, and yeah, we'll get started from there. I'm a software at HelloSign. We were recently acquired by Dropbox, as Bob mentioned, if you're interested in a job, feel free to reach out to me. The only reason why that email is public is because it will not be valid in like a month. So, reach out while you can. All right. So what I plan to coverage is, what an OTP release is, what Distillery will do for you, when you're using Distillery, really in the context of how to deal with dynamic configuration and what custom commands are. The one thing I'm not going to talk about is doing hot upgrades. They are something that you might want to do, but I'm not going to go over that. Okay, so a little bit of background about the OTP release is what they were built for. At least what I think they were built for, is to handle, a package application release. They are meant to be compiled so that you can ship a payload that targets, a specific operating system and CPU architecture. So if you have a lot of production boxes and nodes that are up and running, you can build it in one spot and potentially deploy it to many places, right? So this is really great for, maybe you have a really beefy build machine and you have really tiny ARM devices. This would allow you to target those very easily. The other nice thing about them, that's what they do. They, small shippable payload to deploy. All right, so Distillery is a tool that turns your Elixir application into a compiled OTP release. And the only reason why I underline compiled here is because it's very easy with Elixir to treat it like a interpreted language. The power of Mix and the interactive Elixir environment, like Phoenix live code reloading and stuff, allows you to treat, as a developer, your application very much like you would an interpreted one. It kind of feels like Python when you run it in a development environment. And there are some, so when you do create a release and you ship it to production, there are some caveats with that. The behavior that you might expect in your development machine is not the same behavior that you're going to expect in production, per se. So we'll get into that. And the first thing I'm going to talk about is, I'm assuming that you have downloaded this from Hex and you're ready to run mix release.init. So let's get into that. We'll dive into a little bit of code here. So the first thing you do after running that command is it will give you this directory rel. And what's in rel is it will give you two files, config.exs and your vm.args. Plugins is empty. I'm not really sure why they just include that there when it's empty, but that's okay. So we're going to look at what rel gives us. So in here, at the top, this is how you include your plugins. What plugins are they're a way to extend Distillery. We don't have any, so I'm not going to talk about them. And then the next thing down here is you see these settings as your default release and default environment. So your default release, this atom, what it will do, if we see on line 23, you can have multiple releases defined, and it will just say the default just targets the first one that's listed. That's all that's doing for you. And then the default environment here on line 8 is whatever mix environment you're using when you run mix release. And then if we go down here to environment, you can have multiple of these defined, and you can run mix release with different arguments to target different environments. But the important thing to note here is really the settings and what they're doing for you. And this one right here, I feel like is the superpower. This is the one I love the most, is include Erlang runtime system, right? The reason why I feel like this is a superpower is because of what it gives your ops team. Your ops team's gonna love you, because if you have multiple machines in different environments, it gets rid of a system dependency, right? So so include Erlang runtimes. Let me take a step back. What it does is it's taking that and it's putting it in your code when you ship it. Okay, it's copying the one that you're using in your build environment so that you can deploy that and run that with your code. So again, going back to the ops teams and why they love it, they don't have to manage an Erlang and Elixir version. They don't need to set that up on like a QA box, on a production box, on a staging box. And the other really convenient thing as a developer is if you use tools like ASDF, you can version the Elixir and Erlang versions that you're actually using when you write your code. So if you need to debug something in the past, you know exactly which version and what environment you were running. So this just gives you some really nice consistency, and it lets you move a little bit faster. So this next thing that we're setting is the source, include source. I mean, that does exactly what it sounds like. It's saying all the source that I'm compiling, copy it into the application directory. I mean, you can argue it's more secure that way, but I think it just really gives you smaller payloads. The cookie, so this is the magic cookie that you set nodes up with. You're probably not going to want to set this here. You're probably going to want to pull that from the environment from somewhere. The vm.args, this is the file that you're going to reference. So if we go, so this is the vm.args file here. So what are vm.args, right? This is a way for you to specify how you want the Erlang virtual machine to run. So if you want to have something like a garbage collector run on a setting that you define, this would allow you to do that. So the first one that it includes up here, there are a list of a lot of settings. I'm just going to include the ones that are handed to you. So the name, so this will name your node so that you can reference it. The cookie, again, is pulling that cookie that was in your release file. And then the SMP, that stands for symmetric multiprocessing. I can never say that word right. And what that's doing is, what that says is it looks at how many cores are on your machine, and it says spin up this many processes so that I can utilize all the cores on my machine when it's set to auto. Anyway, yeah. So if we go back here and we look at the environment in dev, the only big change here is this dev mode. When that's set to true, all that's doing is when you compile your application, is it's symlinking the compiled code into the release, so that you can test your releases a little bit quicker. Then down here, let's go to the release. So the name of this application is toy. This release here is just a release name. So my release name here is toy. Then I have a version. This current version is set in your project's mix.exs folder, or that's what that function is grabbing when it runs. And then, usually if you're, so that's one way you can set the version. A lot of times what people will do is they'll use a git hash instead, and that might be something that you want to consider doing. Applications, so setting these applications is mostly setting, if you have like an umbrella application, all of the apps in that umbrella application that you want to be included, as well as how you start up those applications. So permanent, there are 4 options. There's permanent, there's load, there's transient, and temporary. So what permanent does is it says if this application fails for some reason, kill the VM. Transient, I believe, will when an application fails, it will want to restart all the applications. And then temporary says if that application fails, just keep running business as usual. And yeah, so next is we'll try compiling. We'll do a mix release. And actually, I should probably show you the actual code that we're going to run before we do this. That would be a good idea. Okay. So toy.ex and config. Okay. So down here, we just have one function. We're getting this variable in the configuration, codebeam sf. So if we go to the configuration, we do a system call to get an environment variable named codebeam sf. So this is interesting here because this is a function, right? And what's going to happen is this is going to get compiled to like a constant variable. And that's probably not what you intended. So if I just show you what's in that variable really quick, it's 2019. Okay. So we just built this using mix release. How you are going to run that is you're going to go to the path right here, and the first thing I'm going to do is type help, because the application that gets built actually has a lot of included commands, and the help is really a convenient way to just list out what it's going to do for you, and or list out what's available. And the one that we're going to use right now is console, so that I can show you what's happening under the hood a little bit. Okay. All right. All right. So we have this, and then it's yeah. Okay. That's the name of the function. So the first thing that we see is right that we got the system environment variable that we expected this time around, but you'll also notice that it's giving you a string, right? So that is not always ideal. You might not always want a string. We'll talk about that a little bit more later, but let's just go on ahead and change the environment variable to 2018. And let's not compile it again, but let's run it again, just so that I can verify I'm not lying to you. Oh. Oh, no, because it's already defined in my environment. So if I print and it should be set right here, right? Yep. So it's 2018. So yeah, so what's happening when you compile it is so the compiler is doing a system call and setting that to a static variable. And that's probably not the behavior that you intended when you did that, when you wrote this. Maybe it is if you're well-versed in what the compiler does for you. But you should know exactly what it's doing for you, and that's the point. So how do you work around this? Erlang has this other thing called replace OS vars, and essentially you end up writing all of your configuration in a different format. You do it, you replace these calls with a $sign around some curly brackets. And then we'll do a mix release again, compile this. And when you run this, now you have to do replace OS vars equals true. And yeah. And now we have 2018. And you might think, it was compiled at 2018, and you'd be right, it was. So let's change it again to I don't know, something different. Let's just go on ahead and run that. And that's how you do that. But again, it's a string, and that sucks. There is also another caveat that's really easy to fall into. I've done it more than once. So if we go here, let's go to lib and back to the application, which is doing something like at code beam. And then you get the application environment variable here. If you do that, the rule of thumb is anything that's not living inside of a function, right, a def, it's going to be set to a static variable. It's going to do that at compilation time. So let's not do that. Anyway. Moving on. Right. So get. Okay. So right. The next thing I wanted to talk about is dynamic configuration. So how do we deal with dynamic configuration, and what does it do for you? So when Distillery 2 launched, they put in something new called configuration providers, right? And this is a way for you to reference things that are not just strings in configuration. So I'm going to show you a trivial example, but you can imagine having something like a record or a map, and being able to get some more usage out of that. All right, so let's do get DC. All right. And what changed here is your config, And the other thing that changed is in your config, you have a default file and and your configuration will have changed a little bit as well. So the big thing in the Distillery configurations is this guy, set default config provider to toml.provider. This is one that's sort of provided by Paul Schoenfeld. And so he wrote this provider. And this is how anybody can make a provider, and this is how you reference them. So right here, we're referencing, in the production environment, we're referencing a toml file in my home path, right? So next, I will show you, this one is not in my home path because so this is for my development environment. And my development environment also includes this guy, an overlay, which is copying that file into my release path. So now when I run this, I don't have any other configuration. Like that key that used to exist in this file is completely removed. So when I compile this, mix. And I go back. Right. So I get the result I want in an integer, and that's how you would get some more flexibility with this. And yeah, that's essentially how the dynamic configuration works and what the configuration providers will give you. The next thing that I would like to go over is custom commands. So what these things are, another sort of drawback to Distillery from Mix is that you can't. Mix gives you a lot of built-in functionality. Like if you have Ecto in there, it gives you like a task to run your database migrations, right? And you might want to run those. You might want to run your database migrations in production using a release, and you're going to have to build a custom command for that. That's kind of annoying, but at the same time, it does give you a lot more control over your production environments. So how do you build these? So I go to a different branch here where I've already set up for you. And we'll look at the release folder. I have this folder here called commands, and a migration shell. Right here, this is a function that you would call to the VM to target a specific function with specific arguments. Down here in your file, your release configuration, you are going to have a command. You're going to define all the commands that you want to run, and this is going to be the name of the command in your when you run that, and this is the path to the shell function that you want to use. Next is just looking at the actual custom command and what a release task might look like. So if I go in here and I go into, I look at the release task. The first thing in here is, so I wrote this as a macro because you usually have some boilerplate that you're going to write a lot. And this is all available basically on documentation, just not written as a macro. But the start app is essentially starting an application. So it's like loading the supervision tree. The load apps are not starting an application. It is loading code for you to reference, and then repos are starting links to your database repos so that you can actually access your database. And this prepare command, this prepare function here, is just giving you some output saying, make sure things load properly, make sure it starts, and make sure you can reference. And then this is the actual release task. So we just use the macro. We list all of the apps that we want to start and load, and the repository that we want to reference. And then we just call prepare in the task itself before we write any of our domain-specific code. And then right here, all this is doing is getting a list of the migrations that have run. So if we compile this, and I do a help. There at the bottom, you can see the name of the command that we just built. And now we can run that to get the output. Right. So yeah, it looked at my database. There's the migration that was run, and that's the status of it. And that's essentially it for a custom command. Yeah. So I've included a command appendix here at the end in case you want to download slides later. This should give you an idea of how to just do this stuff. I've also included a link to the code repository with all the branches updated. So if you want something to reference, it's very easy to reference. And yeah, that's all I had for you. So please let me know if you have questions. I'd be more than happy to answer.
All right, first question.
I was just wondering, could you show us an example of I think it was a TOML file?
Yeah, so sure. The TOML file, let's actually go to the branch, because it should be in here. So if we go into config, so I have a default one, and then there's also one in my home path. So the one in my home path can be dynamically changed. The one that I set in the config gets copied, and that will always be the same because that gets copied. But the default one looks like this. So it references, so this references like like in your configuration file. Let's just open that really quick. config.exs, right. So that like toy in the square brackets there is kind of the same thing as this right here on this side. And then, that's interesting. I have shell level instead. I forgot to update that. But yeah, so that should have said code beam instead. So I probably messed the code up there. I will update the branch so that reflects it. Let's see what's in the home path. Yeah. Sorry.
I'm just curious what the format of this is. This an Elixir file?
No, this is a standard format, like a standard configuration format that that anybody can use. So you could think of it in the same way that you think of JSON, right? Yeah, so it gives DevOps a little more flexibility.
It's kind of a reaction to the complexity of YAML. So it's basically like Windows INI style files. You see those a lot in Windows and Python, but with a little more semantics on top of them. Like for example, this came out as an integer because that's sort of specified, and you can have nesting in the namespaces, whereas INI files have a flat namespace. So that's what TOML is.
Nice, thank you.
Any other questions?
Maybe I misunderstood, but if you're going with this and you hard code, say 999, that said, if I run it on my production machine, that I specify like nvars, would they be picked up, or I should stop using nvars and just use this file?
So, so if you, well, it depends. It depends what you want. Like if you want to have things referenced in environment variables, one, when you grab them from your configuration, right, they're always going to be strings. So, and then there's still ways to deal with that, but you're gonna have to deal with that in application code, right? So anywhere you reference that, you're going to have to change it to what you expect it to be, which kind of sucks. And then, yeah, sorry, does that sort of answer your question?
Yeah.
Okay.
It answers. It means that if I have some really dynamic values that I need to use, then I should not use this file. I'll just make it whatever transformation to make it the type I need in application.
Right, yeah.
Similarly, we're deploying on Heroku, and so environment variables are kind of the standard thing there. Do you know if Distillery is appropriate on Heroku at all, and if we have options other than environment variables there?
Not on Heroku specifically, but you can still copy the stuff into into the release, right? So you can either reference the file or you can bake it into the file. You can reference a file in a release, or you could bake it into the release itself and reference it that way. One of the things that can be bad about environment variables is, from a security perspective, is somebody might be able to attack you and print out your environment variables, and that would reveal a lot of your secrets. This offers another layer of misdirection. So if that's important to you, that's another reason why you do this.
But I mean, you can use environment variables as a config provider. Like that's kind of what he demonstrated at the beginning. So you could use this on Heroku, like as part of the build phase. You build a release and then you just run it. Any other questions? All right, great. Thank you, Ken.
Yeah, thank you.